next few videos we're going to be attempting wireless power. Now what wireless power is the transmission of electrical energy without wires, funnily enough, because of the name. So there's loads of ways to do this, but I'm going to be going down a specific route in my attempts. The wireless power system that I'm attempting involves lasers. Now, the way the system works is you supply electrical energy to the laser array, which then converts that electrical energy into light energy. Now that light energy gets transmitted to a receiver array, which consists of photo LEDs. They absorb the laser light and reconvert it back into electrical energy, and then that energy gets distributed where you need it. Now the applications of this, if I get it working, are quite literally endless. Right, so this is the prototype I've got running so far. You've got two 1.5 watt LEDs, which is a total of 3 watts output from this apparatus here. The light then travels across this gap and gets absorbed by these two LEDs acting as photo LEDs. Now, the power absorbed by these two photo LEDs gets supplied into this terminal block, which gets distributed into this voltmeter and this ammeter here. Now, basically, this half takes in electrical energy and converts it into light to be distributed elsewhere. This half absorbs the distributed light and reconverts it back into electrical energy. Now, it's not very efficient at the minute, which I'll show you now. So, the power supply is supplying 5 volts at 370 milliamps into the 3 watt output laser diodes. Now, it goes across this gap, as you can see, and these two LEDs are now absorbing the laser light. Now, these aren't on, this is all light that's being absorbed from these two laser diodes here. Now, at the minute we have 5.05 volts output, which may seem like a lot and which may seem alright, but it only outputs 5 microamps, which is, to be blunt, worse than useless. So there's going to be a lot of fine tuning involved to get this up to a relatively efficient level, but I think with money and a decent few hours we can get it done. Right, so to increase current to make the circuit more efficient, I could either increase the voltage, which would mean add more laser diodes, which will happen, but if we assume that the current increase will stay constant, so we had 5 volts out with 5 microamps, so that means with every volt increase, there's going to be an increase in 1 microvolt. That's just simply not enough. You could obviously decrease resistance, but there's not much resistance, and if it's resistance in the wires, then I don't have access to any superconductors at the minute, so I'm going to have to find another way to do it. Into buffer drivers, what's this? So I've had another idea. Coils, I could use coils. Don't know if that will do anything. I'll try decreasing resistance, as in look at how much wire I'm using there. I'll try and, like, that's a lot of wire. I could make this a circuit board. That should decrease resistance dramatically. And then we'll do that and see if that works. Right, so I've made a second prototype. It's the exact same as the first one, except it's a quarter of the size in every dimension. That was in the aim of trying to reduce resistance, because now it's only connected by a few copper strips. Now, when I was soldering it, I think I've hooked up one wrong, or there's a loose wire somewhere, so it's only inputting 1 LED's worth of input power, so output power even. So if I turn it on, it goes up fine, it's the same. Oh, there we go, it outputs 2.92 volts with an output current of 2.6 microamps. Now, if both were working, I think only 5 microamps would be outputted at the same rate. So here's a closer look at the prototype just tested. As you can see, it is literally just a miniature version of this, like orders of magnitude smaller. Now, there's 2 reasons why this didn't work. The first being there's a loose wire somewhere, so only half of the laser light got converted into electrical energy, so there was only 2.6 microamps, I think it was, whereas this outputs 5 microamps because both LEDs were operational. That brings me to the second point why it didn't work. It would have been exactly the same output as this, but the whole point of miniaturizing it was to reduce resistance, so we can rule out resistance as a factor to why there's not enough current. Now, in the next video, I'm going to add more lasers, develop a new prototype, and hopefully we can maybe get it working. So that's all for this week, and I'll see you next week.